What if the universe is younger than we think? An intriguing question, isn't it? Let's dive into this cosmic conundrum together. Our understanding of the universe and its age is largely based on a framework known as the Standard Model of Cosmology. Picture it as a cosmic blueprint, a set of rules that governs how our universe functions. This model estimates the universe to be about 13.8 billion years old. This age is derived from measurements of something fascinating called the cosmic microwave background radiation, or CMB for short. The CMB is like the universe's baby picture, a snapshot of the cosmos just a few 100,000 years after the Big Bang. The European Space Agency's Planck mission has been instrumental in studying this radiation, providing us with the most accurate measurements to date. According to the Standard Model, our universe is flat and dominated by two mysterious entities, dark energy and dark matter. These unseen forces are believed to be driving the universe's expansion at an ever-accelerating rate. This model isn't just a set of abstract ideas, though. It serves as a foundation for supercomputer simulations that can illustrate the growth of large-scale structures in the universe. We're talking about galaxies, galaxy clusters, and massive chains and walls of galaxies. But here's where things get tricky. These computer simulations, as impressive as they are, have recently come into conflict with new measurements. These measurements are of the motions of pairs of galaxies, and surprisingly, they don't align with what the simulations predict. A team of astronomers led by Guo Qi from the National Astronomical Observatories of the Chinese Academy of Sciences has been studying pairs of satellite galaxies. These satellite galaxies are small galaxies that orbit around larger ones, much like how our moon orbits the Earth. The team's findings are causing us to reconsider our current understanding of the universe's age. However, new measurements of the motions of pairs of galaxies are challenging this established belief. Yes, it's a cosmic curveball, one that could potentially change our understanding of the universe and its age. But remember, science is a journey of discovery, and every new finding, every unexpected result brings us one step closer to unraveling the mysteries of the cosmos. A recent study led by Guo Qi from the National Astronomical Observatories of the Chinese Academy of Sciences brings a new perspective into the mix. Guo Qi and his team delved into the cosmic depths, studying the movements of galaxies within galaxy groups. These groups are like cosmic neighborhoods where a few large galaxies are joined by a swarm of smaller ones, all interconnected in the vast web that spans our universe. The team turned their focus to data gathered by the Sloan Digital Sky Survey, or SDSS for short, which observed over 800 galaxy groups within a cosmic stone's throw of approximately 600 million light-years from Earth. They zeroed in on the most massive galaxy in each group and meticulously measured how pairs of smaller satellite galaxies on opposite sides of these massive galaxies moved. What they found was intriguing. The fraction of satellite galaxies that were counter-rotating, that is, orbiting the large galaxy in opposite directions, was higher than what computer simulations predicted. These simulations, like the Millennium simulation and the Illustris TNG 300 model, are based on the Standard Model as described by the Planck mission. They depict a universe dominated by dark energy and dark matter, expanding at an accelerating rate. This higher fraction of counter-rotating galaxies suggests that they have only recently fallen into orbit around the larger galaxy of the group. Over time, galaxy groups are expected to reach a dynamically relaxed state, with most satellites co-rotating. If galaxy groups had coalesced when the Standard Model suggests they should have, then the fraction of counter-rotating satellites should be smaller, but it's not. This discrepancy between observation and prediction presents a challenge to the Standard Model. Guo Qi's study has shown us that the universe might be behaving a little differently than we thought. The universe's age-old secrets still keep us guessing, and every new discovery brings us one step closer to understanding the cosmic dance of galaxies. So what does this all mean for our understanding of the universe's age? Let's delve into the implications of these fascinating findings. The study suggests a higher fraction of counter-rotating satellite galaxies than what was previously predicted by computer simulations of the large-scale structure. This means that these satellite galaxies are orbiting the larger galaxy in the group in opposite directions. Now, this might seem like a small detail, but in the grand scheme of the cosmos, it's incredibly significant. This counter-rotation is a natural occurrence if the satellites have only recently fallen into orbit around the larger galaxy in the group. Over time, galaxy groups and clusters are expected to reach a dynamically relaxed state, with most satellites co-rotating. However, if these galaxy groups and clusters had formed when the standard model suggests they should have, then we would see fewer counter-rotating satellites. The fact that we observe a greater fraction of these satellites suggests a problem with the standard model. In essence, the satellite galaxies appear to be in the process of falling into their respective groups, indicating that this assembly may still be ongoing. As Chi, the lead astronomer of this study, noted, there's a stronger signal of ongoing assembly compared to simulations with Planck parameters. So what does this mean for the age of the universe? Well, it could suggest that the universe is younger than the 13.8 billion years indicated by the Planck observations of the cosmic microwave background radiation. However, it's important to note that these findings don't provide a quantitative estimate of the universe's age. There's still too much uncertainty in the motions of the satellite pairs and the models of how groups form to place a firm figure on how much younger the universe could be. This research has given us new insights into the universe's timeline, challenging our previous understanding and pushing us to dig deeper into the mysteries of the cosmos. This could potentially shake up our understanding of the universe's timeline. However, there's still a lot we don't know. As intriguing as these findings are, they are not without their limitations. The measurements and observations of our universe are intricate and complex. And just like a puzzle, we're still trying to piece together an accurate depiction of the cosmos. These findings suggest a tantalizing possibility. The universe might be younger than the estimated 13.8 billion years. But let's not get ahead of ourselves. There's a significant degree of uncertainty in the motions of the satellite pairs we've been discussing. These satellites, remember, are galaxies that have recently fallen into the gravitational pull of a larger galaxy within their group. The models we use to understand how these groups form also contain a fair amount of uncertainty. These models are based on the standard model of cosmology, a model that describes a flat universe dominated by dark energy and dark matter, expanding at an accelerating rate. But as we've seen, the behavior of these satellite galaxies has thrown a wrench in the workings of this model. Does this mean we need to revise the standard model? Not necessarily. It might mean we need to refine our understanding of galaxy group formation and the movements of satellite galaxies. It might also mean we need to improve our simulations, making them more precise, more reflective of the real universe. The researchers behind this study are cautious in their conclusions. They've highlighted an inconsistency, a discrepancy between what we observe in the universe and what our models predict. But they've also acknowledged that this doesn't allow us to determine the age of the universe with any more precision. So, while we can't yet say for sure how old the universe is, this study opens up exciting new possibilities for further research. It's a reminder that the universe is a vast, complex place full of mysteries waiting to be solved. And every new discovery, every unexpected observation brings us one step closer to understanding our place in the cosmos. In the grand scheme of cosmic time, our understanding of the universe is still in its infancy. The recent findings by Guo Qi and his team challenge the conventional timeline of the universe, suggesting that it might be younger than the estimated 13.8 billion years. This conclusion stems from the observation that satellite galaxies are still falling into their respective groups, a process that should have concluded if the universe was as old as we originally thought. However, this research doesn't provide a definitive age for the universe. There's still much to learn and understand about the formation of galaxy groups and the precise movements of satellite galaxies. The cosmos continues to be a vast, mysterious, and fascinating arena full of surprises that challenge our knowledge and assumptions. In the end, it's this state of constant learning and discovery that makes the study of the universe so intriguing. As we continue to explore and study the cosmos, who knows what new revelations await us? Stay curious and keep questioning.